Welcome to Division of Functions. And now that we have reviewed our factoring skills, working on division with functions is going to be a snap. The notation that you'll see is f of x divided by g, or f of x over g of x. So the first thing we need to do when we're dividing function is put the first function as the numerator, or the top of the fraction, and the second function as the denominator, or the bottom piece, and then simplify. Now we need to define our function, and what that means, because division by zero is not defined, it's not allowed, it's illegal, we need to determine the values that are going to create a zero in the denominator, because they would create an undefined answer. We're going to deal with this a little bit later on in more detail, but I just want to set the stage. So let's move on and do example 18, which is already done for us. And if we look at it, it says to find f of x divided by g of x when f of x is 3 and g of x is 4x. So we replace f of x and g of x with their equivalent expressions in the numerator and the denominator, and see if we can simplify it. See if we factor the numerator and the denominator, and if anything cancels. In this case, it's already simplified, so I don't need to do anything, and I just need to determine what's going to cause a zero in the denominator. And to do that, we take the denominator of 4x, set it equal to 0, and solve for x. So this tells me x cannot be 0, because that will give me a 0 denominator, and that is illegal. Let's move on to example 19. Example 19 says to find f of x divided by g of x when f of x is x squared minus 1 and g of x is x plus 1. First thing we do is replace the notation with the expression, so I have x squared minus 1 over x plus 1. Simply, wherever I see f of x, I'm going to put in the expression, and where I see g of x, I put that in. Now we need to simplify. So we need to factor the numerator and the denominator of each of those if we can, and cancel factors. Looking at my numerator, x squared minus 1, I notice that it is the difference between two squares. So my numerator is going to be the square root of that first term as the lead in both binomials, 1 plus, 1 minus on those second terms. The denominator, x plus 1, I can't do anything with that x plus 1. So we are done. Now we need to look for common factors, common binomials that occur in the numerator and the denominator, and then I can cancel those out. I have an x plus 1 in the numerator and the denominator, so my solution is what's remaining, which is just simply x minus 1 in this case. Now we need to determine the domain. What inputs can I put into this without causing a zero in my denominator? To do that, you need to go back to the original factoring. In this case, I have x plus 1 in my denominator, and set that equal to 0. Figure out that if x equals negative 1, I am going to have a 0 in my denominator, and I will not be able to have that as an input in my solution set. So x cannot be negative 1. And the way we write this in set notation is we put our set out, all values x, such that x does not equal negative 1. And then we end our set. That's how you'd see it written. So set notation, x such that x does not equal -1 when we do our division. Let's work through the guided practice together a little bit. I'm going to do one, you'll do one, and then we'll have one where you'll bring it into class. Oh, looks like I didn't erase very well. Hang on a second. There we go. Now we have a clean slate to begin with. Number 1 says to find h of q divided by j of q, where h of q is q squared minus 3q plus 2, and j of q is 2q plus 5. So my first step is to replace and put my numerator, my first expression in the numerator, so I'm going to have q squared minus 3q plus 2, and my second in the denominator. Step 1, set it up as a fraction. 2, factor both the numerator and the denominator. Well, my denominator is already factored. I'm going to put that in just to get it over with. Now I need to work with that q squared minus 3q plus 2. My questions have not changed. Greatest common factor between q squared, 3q, and 2. Only have 1, so I can't do anything there. 2. Is it special? A squared minus b squared. No, not in this case. 3. Is my coefficient of my squared term 1? This is the process I need to do. In doing that, I can put my binomial parentheses out, and I know I'm going to have the square root of the first term in each binomial. Let me extend this line a bit. Now, I need to find factors of a positive 2 that add up to -3. So factors of 2 that have a sum of -3. So to get the positive, I need to have a negative times a negative because my sum is -3. -1 times -2, when I add them, I get -3. So I put those in my binomials in my numerator. Now I see if I can cancel anything. Q minus 1 times Q minus 2 divided by 2Q plus 5. Well, I can't cancel anything. So I'm good there. Now I need to determine what my excluded values are. And doing that, I take the binomials in the denominator, in this case 2Q plus 5, set it equal to 0, and solve. Subtracting 5 from both sides, and then dividing by 2. Q cannot be -5 halves. So writing that in notation, all values for Q such that Q does not equal -5 halves. You could also have that written as a decimal if you like. So that's the solution for number 1. Go ahead, try example 2, and when you're ready, restart the video and see how you did. Looking at example 2, we have f of x divided by g of x. So my first step is to replace f of x with the expression. So I have x squared minus x minus 20 over g of x, which is x squared plus 7x plus 12. And I have an extra addition sign on this one. I'll get rid of that before I post it to the website. So now I need to find and factor my numerator and my denominator, asking those same questions. Let's just work one at a time. Greatest common factor. Let's work at my numerator. Do I have a greatest common factor? No. Is it special? Is it the difference between two squares? No. Does my coefficient on that squared term equal 1? Yes, that's the one I'm going to do. So I'm going to come over here, put out my binomials. I need factors of negative 20 that add up to x, negative x. I'm going to have x minus 5 and x plus 4 are the two factors you should have found. When I multiply them, negative 5 times 4 is negative 20. Add them, negative 5 plus 4 is negative 1. Now I do the same thing with my denominator. Are there or is there a greatest common factor? No. Is it the difference between two squares? No. Is my coefficient on that squared term 1? Yes. So I come out and I put out my binomial parentheses, the square root of the first term, and two factors of a positive 12 that add to 7. That's going to be a positive 3 and a positive 4. 3 times 4 is 12. 3 plus 4 is 7. Now I look for common binomials in the numerator and the denominator, and I can cancel those like terms. I'm going to cancel x plus 4 from my numerator and my denominator, which leaves me a quotient of x minus 5 over x plus 3. Now, I need to determine my excluded values. So I need to work with my entire original denominator. And what we do here is we take each binomial, x plus 3 and x plus 4, set each of them to 0, and solve. Because if I get a 0 in the x plus 3, my whole denominator will be 0. So subtracting 3 from both sides, x is negative 3. Subtracting 4 from both sides, I get negative 4. So my notation is, this is my solution, and I write my notation, all of x, such that x does not equal negative 3, comma, x does not equal negative 4. That is the solution. I hope you got that correct. If not, don't worry, we're going to practice this a lot. This really has confused students for years now. Go ahead and do number 3 on your own and bring it with you to class next time we get together, along with your completed note-taking guide and your score results from the online self-check. We'll see you next time. Until then, have a great evening.